All right, ladies and gentlemen, we're going to be looking at some questions today from the final exam. So this is not actual going over your individual results. This is just compiling some of the data for the questions that students missed. So you should have your worksheet in front of you. We're going to go kind of quick, try and do as many as we can. All right, on number 1 and number 2, it says determine whether the ordered pairs will form a straight line when plotted. So again, what I asked you to do was essentially to find the change of x and the change of y. So do this with me, please. That is going to be a plus 2, and another plus 2. So that's looking pretty good. Now remember, if one is slightly off, that does not necessarily mean that it's wrong, but it has to be a constant change. So coming over here, we're going to have a subtract 2, and then we're going to have a subtract 3, and then we're going to have a plus 3. So since all the x's are the same, all the y's have to be same to have a constant change, which would be a slope of a line. So unfortunately, number 1 is non-linear. This is not a line. Number 2, you're going to do the exact same way. Look for a constant change, please. All right, on 3, 4, 5, and 6, these were supposed to be some easy points. All you had to do, again, was remember that this is x and this is y. You do a little bit of substitution, and you see if your answer is correct. Again, this has a 9, so we are looking for 9 equals 9. So on my x, I simply have a -6. That's going to multiply by a -2. And we really think this is where some of you may have gotten confused, was with any form of the fraction part. But again, remember, all you're really trying to do is cross-cancel. So I've got a -6 multiplied by -2, which is a 12. A 4 becomes a 1, a 12 becomes a 3. A -1 times 3 is a -3. Does 12 subtract 3 give you 9? Yes, 9 is equal to 9. So this would be a solution, which means the point is on the line. Where the other ones, it might work, it may not work. So again, if it has a fraction involved, really just cross-cancel, please. I don't know why that was not a higher percentage problem. All right, the next two, 7 and 8, you're trying to describe the transformations for part A and part B. And you had a question just like this. So again, you're going to start with triangle ABC, which is this original triangle here, and you're going to try and figure out how that becomes the prime 1, which is right here, A prime. Then the prime 1, or A prime, how does that become a double prime? Now, if you remember, we have our translations, reflections, rotations, dilations. If you notice, the sizes are the same, so it's not going to be a dilation. So how does A become A prime? But also C becomes C prime and B become B prime. My initial thought would be it appears that it might be a reflection. Because if I count to the highlighter, that's 1, 2, 1, 2. B is 1, 2, 1, 2, and C is already on the line. That looks pretty good. So the first one would be reflection across. And we think that is going to be the x-axis. All right, now the question is, how does this A prime become a double prime? Well, it's not a rotation because the image is not turning. It's not another reflection. It has to be a translation. So you're really just going to figure out how many you count. You count up 1, 2, and write 1, 2, 3, 4, 5, 6. So we would say translation. And you can use the words. But we do our x first, so maybe we actually do the 6 and then 2. So that would be right 6 units, and then up 2 units. If it was the symbols, that would be an x plus 6, because that's to the right, and up 2 would be y plus 2. We think that it's primarily the rotation issue, which is number 8. You're going to notice that to get from A to A prime, it is a rotation because the image is turning. All right, looking at 9, determine which rate of change is greater than the one shown in the graph. So I tried showing you this recently, And let's go back to it. It's really just finding the slope first. That's rise over run. So the given slope, our rise is 1, 2, 3, and my run is 2. So my slope is positive, and it's going to be 3 over 2. So the way that I tried telling you is maybe you can put it into a decimal, or you could even put it into a common denominator. If you'd like to, notice that C is the same slope. So obviously that's not greater, so it can't be C. So if you'd like to, again, you can change it into a decimal. So that'd be 1.5. Well, 2 is definitely greater than 1.5. 4/3, we did that recently. 4/3 is 1.33, well, repeating, right? So that's not greater than 1.5. So I have it down to 2 more here. So again, you can do division if you'd like to. Well, 5 divided by 2 is 2.5. Notice I'm not really worrying about the negative signs. So that's greater. What about 9 over 4? 4 goes into 9 2 times. 2 point something is definitely greater than 1 point something. So there we go. So again, put it into a common fraction with a common denominator or decimals. Decimals, kind of thinking about money, it might be pretty easy for you there. All right, for this one, solve for x, then find the value of 13x subtract 5. So let's see here. We've got a few ways to do this. I know that these are not equal to each other because they're not congruent. There's no connection with the corresponding, not vertical, anything like that. Ooh, but you know what? This is corresponding to this. And these together are supplementary. So if this is 94, this would have to be the difference, which is really just 180 subtract 94. So that means this mini equation here is going to be equal to the difference. That's going to be a 6, so that gives me 100, so 86. So the value of 13x subtract 5 is 86 degrees. Now I need to find my x. So I'll allow you to finish this equation to find the x value. But again, I did corresponding, and that's supplementary. Supplementary is 180. So if this is 94, this has to be 86 because I subtracted it and found the difference. All right. All right, 11. Triangle ABC is reflected across the x-axis and then translated left 6 units to form A double prime, B double prime, and C double prime. Select true or false for each statement. Side BC is the same length as side B prime, C prime. Well, the side is going to be the same thing every single time. So yeah, that is true. Angle B has the same measure as angle B prime. Yeah, that looks pretty good as well. Side AC is longer than A double prime C prime. Well, that's false because, again, the lengths are the same. Angle B prime has the same y coordinate as C double prime. So let's see. Angle B prime is right here, and that's going to be a y coordinate of 1. So B prime is the coordinate of, let's see, that's going to be 2, 1. And C double prime, that is left 1, 2, up 1. So C double prime is negative 2, 1. So yeah, if you notice, they have the exact same y coordinate. Angle C prime has the same x coordinate as B double prime. So let's see, C prime zooming in a little bit. C prime is 4, 1. And B double prime B double prime, that is negative 4, 1. And the question says the same x-coordinate. If you notice, the x-coordinate is 4 and negative 4, so that is not the same. That would be false there. All right. Write an equation in slope-intercept form for the table. Count the slope backwards to find the y-intercept. That's the hint. Because again, we need to know if x is 0, that's the y-intercept. So let's find the change first. So it's plus 3 and all plus 3. Looks good. And this would be plus 2, it looks like. Remember, your slope, though, is a change in y over change in x, which is going to be a positive 2 divided by a positive 3. So my slope is 2/3. And once I know my b, then I can put my equation together. My equation, again, is going to be y equals mx plus b. So that's going to be y is equal to 2/3 x, and then we got to find that last part right now. So again, the hint is to go backwards. So I need to get to x is 0. And if I'm counting by 3s, if I go backwards, that would actually get me to my 0 that I want. So 0 plus 3 is 3. 3 plus 3 is 6. So I'm good there. All right, this one, again, it's all plus 2s. So if I count backwards, 0 plus 2 is 2. 2 plus 2 is 4. So hey, my y-intercept is 0, 0. So since it's 0, 0, I really don't need to put anything at the end of my equation. If it was 0, 2, I'd put a plus 2. If it was 0, negative 3, I'd put a negative 3. So I am good there with my equation. You're going to do the same thing on number 13. All right, number 15 and 16, it wants us to convert it into a fraction. So the way that I need you to do it is, hopefully you can remember, I said we need to make an equation. So I'm going to write x is equal to 1.2, and then it's repeating 9. So if that's x, what would 10x be? Now, if you remember, on 10x, it's really just moving your decimal once, because if you multiply something by 10, that would give me a 12.9, and remember, it's still repeating 9. And then I got to do a 100x, which really means I need to move it 2 spaces. So that'd be 129.9, and it's still repeating. Because again, in order to convert it into a fraction, we need our repeating decimals to be able to eliminate. So if I set up an equation like this, and if I subtract, that's going to give me a 90x is equal to, well, the repeating eliminates. 9 subtract 2 is 7, 117. So we're going to go ahead and divide by 90. And this does reduce again. 1 plus 1 plus 7 is 9, which means 117 can divide by 3. And so can the denominator. So 90 becomes a 30, 117, and I'll actually let you finish that over here doing your elementary division if you need to. So go ahead and do that quickly. Practice your elementary division. Three and 1 is 0. 3 and 11 is 3. 3 times 3 is 9. So I got a 39. Oh, but if you notice, it can divide by 3 again. So you could have actually divided it by 9. Looks like I got a 13 over a 10. Let's double check on our answer sheet. Oh yeah, 13 over 10. All right, number 16, find the distance between the pair of points. We've done this before as essentially a right triangle. So if I create a right triangle, it is now a Pythagorean theorem problem. This is a 2 and this is a 4. Unfortunately, this is not a triple. So I need to find side C, which is the hypotenuse again, which is the largest side. So I really have 2 squared plus 4 squared is equal to C squared. So I've got a 4 plus 16. So I have C squared is equal to 20. Now simplifying your answer, well, if I take the square root of both sides, do I know the square root of 20? No. So what we're asking you to do here again is your factor tree. That would be a 2 and a 10, a 2 and a 5. So since it's square root, I'm looking for pairs, which is here, 2. So it's really a 2, what we call radical 5. And we're actually going to be spending more time with radicals in May, right before you move on to high school. Now, if it wanted an estimation or approximation, that's the decimal answer, where you have to make your number line and say, okay, the square root of 20 is in between the square root of 16 and the square root of 25, a little bit closer to the square root of 16, and working out that estimation there. All right, 17, very similar to what we just did there. Number 18, you have a bunch of that true, false. We've done this so many times. Please be very careful. For example, the square root of 48. Well, the square root of 48 is really close to the square root of 49, and the square root of 49 is 7. So it means the square root of 48 is probably 6.8 or 9. 72 divided by 8 is 9. Well, that's going to be a quick, easy one. You just got to put a little bit of time and thinking into that. All right, number 19. A few ways that I taught you how to do this. First way was to think about your coefficients separately. So these behave like normal. So a positive divided by a negative is going to be a negative answer. 10 and 6 can both be divided by 2. So I have negative 5 over 3. The coefficients are different than x's. A negative sign is not the same thing as a negative exponent. All right, so one way that I told you you could do it is you could change the negative exponents by moving its location. So it means the x to the negative 4th power would now have x to the 4th power at the denominator, while the x to the negative 1st power would be x to the positive 1st power at the numerator. The y to the 4th power can stay the same because it's already a positive exponent. And the other one, the y to the negative 2nd power, would move to the numerator to become a positive 2nd power. If you didn't like that way, you could always do the subtracting of the exponents at the location of the larger exponent. So it means the x's, you would do the subtraction at the denominator because negative 1 is bigger than negative 4 or greater than negative 4. And for the y's, you'd do it at the numerator. It would be 4 subtract negative 2. So as we clean it up, negative 5 over 3 stays the same. Your y's, you just really put them together. 4 plus 2 is a 6. And your x's, you reduce. A 1 subtract 4 is a 3, but that's at the denominator, or really a 4 subtract a 1. And there we go. All right, just a few more together, and then some are on your own. This is due tomorrow before you enter in class for testing. Number 20, the way I told you to do it again was to look at your base. This is a triple, a 9, 12, 15. And then now we look at the three-dimensional part. This is also a triple, 8, 15, 17. Number 21, determine if the side lengths 8, 10, and 14 form an acute, right, or obtuse triangle. So it's obviously not really going to be a right triangle, I don't think, but we can check. But the way that we're supposed to do this, instead of doing your a squared plus b squared equals c squared, it was called the converse of the Pythagorean theorem, which means start with your c squared. Don't put your sign yet because you don't know which of the three it is. Now we know obviously the biggest side is c, so that's going to be 14 squared. A we usually say is the smaller side. So 14 squared is going to be 196, 8 squared is 64, and 10 squared is 100. So if I put that together, it's 164, 196. Going back up, 196 is greater than So it's obviously not going to be a right triangle. It's going to be acute or obtuse. Now, the way I tried remembering it is acute, like the little one, it's the less than idea. So obtuse is the greater than idea, and this is greater than, so we should say that this is obtuse. All right, 22. Last year, we did this one recently. This year, popular. How many visited together? You're really going to add those together, but in order to add them, you need to have the same exponent. So the 10 to the 5th power has to become a 10 to the 6th power. So your 2.42 really becomes 0.242. All right, last one. We did this one recently, like just the other day, right before, actually on Monday. Let's see, a 12 centimeter tall cylinder shaped cone. So we have pi r squared h is equal to a cone, pi r squared h divided by 3. See, the cylinder is 12 centimeters tall, radius of 5. $25 times 12 is what, 300? Let me see. This was a calculator problem. Yeah, so I got 300 pi. On your cone, radius of 10, what would be the height? Let me move this down just a little bit. So 10 squared is obviously 100, and if you divide that by 3, that's going to be 33.3 repeating pi h. So if I divide both sides by that, again, the pi symbols will divide out. So on my calculator, I'm going to type that in. Let's see if it comes out. Filling up the screen with a bunch of 3s. It comes out to essentially 9. So the height would be 9 centimeters. All right, whatever you did not finish, that is your assignment. Again, this is due Friday at the very beginning of class. Want to remind you for the beginning of our state testing, you need to have your cell phone off. You're going to have it in your hand. You're going to prove it to me. It is off. Pencil ready to go, and obviously this worksheet. All right, be awesome.